The sky just went black, and there was no warning, no eclipse announcement, nothing to explain why you're suddenly staring at stars that weren't visible 3 seconds ago. A car alarm screams somewhere behind you while a dog starts howling in the distance, and disaster Twitter is already spinning up threads about the frozen hellscape coming to kill everyone you love. Movies trained you for this moment, all that instant freezing and desperate survival while cities go dark and civilization collapses around the protagonists. What the movies skip over is that temperature barely moves. The ocean doesn't notice anything happened, and the biggest threat isn't the missing sun at all. Your own nervous system becomes the problem. This video covers what actually happens during 5 minutes of impossible darkness, from the temperature drop you won't feel to the animals calmly heading to bed, the power grid scrambling to compensate for vanished solar generation, and the 200,000-year-old threat response hijacking your brain while the physical world mostly shrugs and waits for sunlight to return. Almost none of this matches what Hollywood sold you about solar blackout, and that's the fine print. The temperature drop you won't feel. Your first instinct tells you the world should already be freezing, since the sun provides all our heat and just vanished completely, so temperatures should be plummeting as you stand there. Apocalypse movies reinforce this constantly, breath fogging and windows frosting within seconds of darkness arriving on screen. Thermal physics tells a different story. NASA measured an average temperature drop of 7 degrees Fahrenheit across the path of totality during the 2017 Great American Eclipse, and the 2024 eclipse produced drops between 8 and 12 degrees for ground temperature, while air temperature fell only 5 to 6 degrees. One station in Saranac, New York recorded the most dramatic shift at 10.3 degrees, which became the headline number that week. 5 minutes of total darkness produces roughly the same temperature change as walking from a sunny parking lot into the shade of a building. That's it. The ground beneath your feet spent all morning absorbing solar radiation, and Earth's surface has thermal mass that stores heat and releases it slowly. 5 minutes of darkness barely registers against hours of accumulated warmth, and air cools even less because the ground keeps radiating stored heat upward into the atmosphere. What gets counterintuitive is the timing. The coldest moment doesn't arrive during the darkness at all, since studies from multiple eclipses show minimum temperature occurring 2 to 15 minutes after the sun returns, sometimes extending to 25 minutes of delay. By the time the atmosphere finishes responding to the blackout, sunlight is already warming everything back up again. Your skin might register a slight chill, but your breath won't fog, nobody freezes, nobody shivers, and the instant ice age scenario exists only in scripts written by people who never checked the thermal mass equations. The ocean does even less with 5 minutes of missing sunlight, and the answer borders on insulting. The ocean doesn't care. Water stores an absurd amount of thermal energy, with a specific heat capacity of roughly 4,000 joules per gram per Kelvin. The top 2.5 meters of seawater holds as much heat as the entire atmosphere above it, which puts the ocean in a completely different category than air or land. 5 minutes without sunlight removes approximately 60,000 joules of energy per square meter of ocean surface. But here's where the math gets humbling. Changing a 10-meter column of water by 1 degree Celsius requires 41 million joules per square meter, and running those numbers puts the ocean surface temperature drop somewhere between 0.001 and 0.015 degrees Celsius. That measurement falls below the detection threshold of most instruments. The 2024 eclipse study confirmed this directly, finding minimal temperature variation over ocean regions compared to pronounced land cooling across the continent. Normal daily variation in sea surface temperature averages 0.1 degrees between maximum and minimum, and overnight cooling lasting 10 or more hours typically produces only half a degree of change. The ocean operates on timescales of days and weeks and months. 5 minutes of missing sunlight doesn't register as an event, just statistical noise that disappears into the margin of error. Something stranger happens in the atmosphere while the ocean ignores everything, and the mystery took 300 years to solve. If you're enjoying this video, please like, subscribe, and comment. I spent a couple days researching this video and would appreciate any hype points and support you can give me. Thanks a lot. The wind does something weird. Strange wind behavior during eclipses showed up in observer reports starting in the 1700s, but measurements kept contradicting each other for centuries. Some eclipses showed wind dropping while others showed it increasing, and the pattern made no sense until University of Reading researchers finally cracked it in 2016 using modern data collection. Boundary layer collapse turned out to be the answer. When sunlight heats the ground, warm air rises and creates convection currents that drive surface winds. Remove the sunlight and convection stops, breaking the connection between surface wind and upper-level airflow in ways that earlier observers couldn't measure properly. Wind speed dropped by up to 4 knots during the 2015 Svalbard eclipse, and the 2017 American eclipse showed average drops of 6 miles per hour. Relative humidity spiked by 20 to 30 percentage points at the same time as cooling air lost its ability to hold moisture. What makes meteorologists excited and everyone else uncomfortable is that wind doesn't just slow down, direction changes too, sometimes rotating significantly as normal daytime circulation patterns collapse and reform into something that shouldn't exist at this hour. Standing outside during these 5 minutes means feeling the breeze fade, the air grow still and damp, and sensing something wrong that you can't quite name. The atmosphere enters a brief twilight state, and your pattern recognition systems will notice even if your conscious mind doesn't understand why the moment feels so off. Weather patterns spanning thousands of miles all hiccup at once, but no storms form, no disasters trigger, and everything normalizes within an hour. The atmosphere handles this better than expected. Animals handle it even better, and their response reveals how biological systems process impossible events. Every animal thinks it's bedtime. Researchers tracked 17 different species at Riverbank Zoo during eclipse totality in 2020, and 76% exhibited behavioral changes once darkness arrived. Gorillas started their evening routines while giraffes walked toward their night enclosures unprompted. Flamingos showed visible anxiety, and baboons started alarm calling as though predators were circling. The threshold for triggering these responses sits at 99% solar obscuration, and below that line, animals ignore the dimming light entirely. Cross that threshold, and their internal clocks flip to night mode regardless of actual time, with no apparent confusion about the sudden transition. Bees produced the most dramatic data when researchers placed microphones near hives during totality in 2019. Complete cessation of flight, hives going silent in unison as though someone had flipped a switch across every colony simultaneously. Before totality arrived, individual bees flew slower and more erratically, apparently confused by fading light that didn't match their expectations for this time of day. Bird behavior follows a strange pattern when darkness ends. About half of all species begin a brief dawn chorus, singing the songs they normally reserve for sunrise even though morning happened hours ago. Returning sunlight triggers the same neurological response as actual dawn, their circadian rhythms resetting based on light transitions rather than time. One giraffe at the zoo continued pacing anxiously for over an hour after the event ended. Most animals returned to normal within 30 minutes, and a few seemed entirely unbothered from start to finish. Animals recover quickly because their stress response matched reality, since darkness actually did arrive and then actually did leave. Your recovery takes longer because your infrastructure and your psychology both operate on assumptions that just got violated without explanation. Your power grid versus physics. California's electrical grid lost 5,000 megawatts of solar generation during the 2017 eclipse, declining at 48.4 megawatts per minute as the shadow crossed the state. The 2015 European eclipse dropped German solar output from 13 gigawatts down to 4.8 gigawatts, with power swinging at 400 megawatts per minute during decline and 700 megawatts per minute during recovery. Grid operators handled both events successfully because they knew exactly when the eclipse would happen and spent months preparing their response. France boosted reserves from 1,000 to 1,700 megawatts. Germany deployed 8 gigawatts of backup capacity, and California procured an additional 100 to 150 megawatts of regulation reserves just for the afternoon. An unexpected blackout eliminates all that preparation time completely. Modern grids depend on precise balance between generation and consumption, and solar farms covering hundreds of square miles dropping to zero output within seconds causes grid frequency to start deviating immediately. Automatic systems shed load to prevent cascading failures, which means rolling blackouts hitting random neighborhoods while operators scramble to understand what's happening to their instruments. The math gets uncomfortable when sunlight returns. Solar output surges back at 700 megawatts per minute across every installation simultaneously after 5 minutes of darkness, and that ramp rate exceeds normal maximum by a factor of 3. More automatic systems trigger, more frequency deviations occur, more potential for equipment damage emerges across the network. The grid survives because it's designed with safety margins for scenarios nobody actually expected to see. Somewhere a refrigerator stopped running during those minutes, somewhere medical equipment switched to battery backup, and a few traffic lights went dark at exactly the wrong moment in exactly the wrong intersection. None of that compares to what happens inside your skull, where the real emergency lives the entire time. Your brain versus 200,000 years of evolution. Sudden darkness triggers your nervous system to treat the situation as a threat, and this isn't fear of the dark in the childhood sense. Your brainstem physically increases its sensitivity to potential threats because darkness historically meant predators had the advantage over humans trying to survive the night. Research on dark enhanced startle response measured reaction magnitude, jumping from 73.93 microvolts to 98.61 microvolts when ambient light disappears, and that response happens below conscious awareness. Triggering takes 30 to 120 milliseconds. Faster than thought can intervene. Reasoning your way out of it proves impossible because reasoning doesn't reach the part of your brain running the calculation. Historical eclipses produced genuine panic before science explained what was happening. The Battle of Halys in 585 BCE ended when both armies stopped fighting, reportedly terrified by sudden darkness descending on the battlefield. Athenian military disaster at Syracuse in 413 BCE resulted from superstitious delay after an eclipse spooked the commanders. Americans in the 1878 eclipse path were convinced the darkness signaled the return of Jesus, abandoning their routines for prayer and preparation. Analysis of 3 million tweets during recent eclipses showed increased expressions of awe, humility, and prosocial language rather than panic. People found totality moving and beautiful because they knew exactly what was happening and why the sky went dark. An unexpected blackout reverses that equation entirely. No warning means no preparation, no explanation means no context, and 5 minutes provides exactly enough time for speculation to spiral into panic across entire populations. Social media amplifies confusion, while emergency lines overload with calls asking what happened, and traffic accidents spike as drivers react to sudden darkness at highway speeds without understanding why their headlights just became necessary. The sun returns after 5 minutes. But the panic doesn't stop immediately. Cortisol levels remain elevated, heart rates stay high, and the feeling that something terrible almost happened persists for hours, even after the explanation arrives and spreads through the news. Your brain will remember this as a close call with disaster, and your brain will be wrong. The fine print: 5 minutes without sunlight drops temperature less than standing in shade. The ocean measures nothing at all. Animals calmly begin evening routines while your power grid scrambles and your psychology fights against 200,000 years of evolved threat detection, screaming that something is wrong. The disaster movie version shows frozen cities and desperate survival against impossible odds. The actual version shows mild confusion, some anxious pets, a brief infrastructure hiccup, and millions of human nervous systems convinced something catastrophic almost happened when the physical world barely noticed anything at all. Nothing freezes and nothing dies. The biosphere registers 5 minutes as a rounding error against the thermal mass of an entire planet spinning through space. What science doesn't capture is that you'll remember where you were standing when the sky went black without warning. The silence when the birds stopped singing, the stillness when the wind died, and the particular quality of starlight at an hour when stars have no business being visible will stay with you. 5 minutes will feel much longer because your brain was never designed for the sun to simply stop existing. The threat was never the missing sun itself. The threat was always what that missing sun did to 8 billion nervous systems simultaneously. All of them running ancient software that couldn't process what was happening. All of them convinced for 5 minutes that something fundamental had broken in the universe. Nothing broke and the sun came back, but your hands will still be shaking an hour later because your body doesn't believe you yet. Thanks for watching. Be sure to like, subscribe, and comment below, and I'll see you in the next one.